For question 5, there is this rocket question. So this question states that this rocket is fired vertically from the launching pad at B. Its flight path is tracked by radar at point A. Determine the velocity of the rocket in terms of B, theta, and theta dot, and the acceleration of the rocket in terms of B, theta, theta dot, and theta double dot. Now, for this kind of question, the hardest part is actually to formulate the first equation. Once you can formulate the first equation, the remaining of the portion is relatively simple. Because when you want to find velocity and acceleration, basically you must find the position function and differentiate it in terms of times. So when you differentiate 1 time you get velocity and 2 times you get acceleration. So the most important thing is to find what is the position function. So in this case, we do know that the rocket is traveling vertically upwards. Hence, this B, this distance B over here, will never change, and this will always be a constant. The only thing that changes is the YP, basically the position of Y over here, will always be changing, and the theta will always be changing. So let's formulate this equation. We can relate this Y and B and theta with trigonometry. So I use tangent theta will be YB over B. Okay? I'll bring over B over the other side so I can make YP the function. Once I got YP, I can differentiate this in terms of time. Because velocity is the time derivative, so it's time derivative of the position. Okay? However, you notice that the function is in terms of theta and not time. So what do we need to do in this case? We need to use implicit differentiation. Okay? And why would this equal to this? It's because, just look at this fraction. A simple way of looking at this is just look at this fraction. So to make, to differentiate tangent theta, we must differentiate in terms of theta. However, to make this equal to this, we must multiply by d theta over dt. Over here, d theta can cancel each other, so this becomes d over dt tangent theta, which is same as here over here lah. Basically, just revise on the implicit differentiation. Once you do implicit differentiation, you're able to get this. Okay? So once you find the velocity function over here, now I need to differentiate this velocity function to find the acceleration function. So I differentiate this with respect to time. So b d over dt of secant square theta and theta dot. So over here there is 2 different functions. There's a theta dot and the theta. So we use product rule. When you use product rule, this is what we get. So theta multiplied by d over dt secant square theta plus secant square theta d over dt theta dot. And we realize again, over here there's this function where secant square theta is not in terms of time. Hence we need to use implicit differentiation and multiply it by d theta dt. And over here, theta dot is already a function of time. Remember, theta dot is d theta over dt. So when you differentiate in terms of time, there is no need for you to do an implicit differentiation. Hence it remains the same over here. Over here, just a matter of doing easy differentiation, and you'll be able to get your answer over here. So this question is actually quite simple to do. It's only the formulation of the first equation is hard. Mathematically, it's not hard at all. It's just the first equation that you do has to be correct. Yeah, so that's it.